Recording has started. Excellent.
You want
Okay.
to start? Okay.
Present the screen. Where is it presenting?
Yeah, it should be told to. Yeah, it's presenting.
Cool.
Okay.
Are you recording now?
Yeah,
Yes.
we're recording.
Okay.
Recording has started.
Yeah, we're recording.
Yeah, it's going.
Cool.
So there are a lot of tools for Selenium. We're particularly fond of the WebDriver because we like to do things in code. Selenium has tools that let you record your mouse movements and stuff like that. Those aren't exactly reliable, especially for regression testing. So we prefer to use the WebDriver, and we recommend that you guys do as well. Now, how do you test that? Ideally, if you have access to the source code of the project you're testing, you should just be putting the tests in that so that they can be running as the unit tests are running. All of the tests are easily usable with the MS test framework. If you don't have access to the source code, that's fine. The WebDriver will launch a brand new browser and just access the page from the outside anyway. So you can just create a unique, independent MS test solution, which is what James and I had to do for our current project. So before we get into what the code actually looks like, it's important to understand the architecture behind that code. And it's important to understand the difference between specification versus implementation. For any given test case, for any single test case, there is a distinction to be made between that test case's specification and that test case's implementation. And it's an important distinction because if we split our code along that very same distinction, suddenly our tests become immeasurably more robust, maintainable, and safe. So we're going to go ahead and use a simple login test example, and we're going to look at a login test case and how that is split between the specification of the login test and the implementation of the login test. So when we look at this login test, we have to ask, well, what does the specification look like? Well, the specification specifies the specific steps to be taken. It is a very general sequence of events that includes the actions that the user takes and the results of those actions. And it's very general, it's very broad. It focuses exactly on what that user is doing. Usually if you have a test case that has steps in its description, almost always the specification is just going to be those steps, the givens, the whens, the thens, stuff like that. Notice how the specification doesn't talk about how any of this stuff is done. It specifically just talks about what is happening. That's important because the how is covered entirely by the implementation, which focuses on the specific elements with the web page and how those elements are interacted with. So for our login page, the specification looks like what you see on the board here. The user navigates to that page, he puts in a password, he puts in a username, etc. He does the series of things in this specific order. He clicks on the button finally and he gets his result. The implementation doesn't care about the what, it just focuses on how all of these elements are interacted with. So for example, it's got the username is a text box, it's got this ID, the password is also a text box with that ID. That information is submitted via a form by clicking on this button with this ID. It doesn't care about what those facts are used for. It just cares about those facts, about that information about interacting with those web elements. So in code, this looks a lot like this. The implementation is represented by what we call page objects, which are simple class data structures. Usually one page object corresponds to a web page. We'll talk a lot about what goes into this page object and how to code up a page object later in the presentation. But specifically, I want to point the attention to, wow, that's pretty blurry. The three lines at the top there, or the three pairs of lines at the top there, are the page object grabbing that web element by its ID, and then wrapping up the interactions with that web element into methods for that page object. Then on the left here, you can see how the specification is represented in code via test methods, which are basic MS test framework test methods. The test methods use the methods that the page objects have wrapped up to enact the specification. So if you recall that the specification of the login test was navigate to the page, enter a username, enter a password, click the button, you can see that's represented as broadly as the specification should be in the test method. And then the implementation has its facts about how these interactions actually occur in its page object. And this is important because if anything about that page were to change, it's incredibly easy to maintain. If, for example, the implementation changes and suddenly the username is entered via a series of drop-down lists or something, for example, because we're just trying to be super cool and unique. Well, we would go into the enter username method of the page object, change that implementation, and all our code should work just fine. Likewise, if the specification were to change and suddenly non-admin accounts don't have usernames, they only use passwords, because our users are really sick of entering usernames, and we want the best things for our users. Well, we go into the specification, and we just get rid of the enter username call. But the admin accounts still use the enter username in the page object, so those tests aren't going to break. So everything's working out okay. It's very easy to maintain, it's very easy to manage, and it's very easy to adjust as the user interface changes.
Okay, I'm going to talk about the architecture of how we build up these things. Basically, for the test classes, the specification side will make a general base test class to start with that all test classes inherit from, and that one just it starts up the driver and opens up the window, and then it might like log in and take you to the first page of your app to launch all of your tests. So if you don't want that whole process to happen for each test, start up a new window, log in, run the test, close the window, start up a new window, etc., which is kind of how that would work if you just left it at that. Then you have to do those steps in a static constructor. So that constructor runs once when the whole thing starts, makes the driver instance, opens the window, logs in, and then it stops and passes over to the actual running of the tests. They all run in the same session. And then once they're done, make a deconstructor, also held at the class level. So you can't actually do a static deconstructor, but we'll cover that step later. There's a workaround. Then when that runs, that just calls driver.quit, which closes the window and gets rid of the memory and resources. And that'll happen once at the end of all tests, when that class is finally destroyed. And then that class just has a reference to your driver and your first starting page. Then there is a possible sort of middle layer, which is base test classes for sort of common areas of your web app, or or just tests that can share some first steps, for example. So those might contain a sort of start page object for those tests, as well as a test initialize method that just navigates there, or also possible helper methods such as go to this subpage, go to that subpage, that are shared by various tests. And then finally, you have your actual test classes. There might be many. which contain the test methods and also possibly any cleanup methods that you might have. That can be done at various sort of layers. We chose to have that done as a class cleanup method on each test class, so that a failure or problem in that code won't cause the test itself to show as a failure if the test part actually succeeded. All right. For page objects, you'll start with a base page, which also that is shared by all page objects, and it has a constructor that basically grabs the driver reference and also does the initialization of certain things that you'll need on all pages, such as the page factory, which we'll talk about later, and also like if you have a weight object in charge of doing all the weights for content to load that you have to start, you'll start it there. Basically just stuff that all pages need, start there. And also it might have some common helper methods as well. Then there's a sort of middle layer for pages that might have shared components. So multiple pages all have this same header bar, so you can have that there. Or multiple pages have the same sort of subpart that is the same on various different contexts. You can have a page object for that and just use it. So that's useful. And then finally, there's the sort of bottom layer or top layer page objects that are basically one per page. Each page has its own, which has references to its various things that you need on that page. And that's what the test methods actually use.
Cool. So how do we actually do any of this? Well, the first thing you got to do is you got to set up your WebDriver. And this can vary to being incredibly simple to being incredibly complicated, depending on the scope of your project. For example, James and I, the scope of our project was you have to use Internet Explorer. It has to be in private mode. Selenium didn't exactly like that, so we had to do a lot of configurations with our driver to get that working. Alternatively, if your thing is just in Chrome, well, you just need to construct a new Chrome driver and launch it, and it should work a-okay. That said, these base steps do remain identical across whatever driver you're using and for whatever project you're going to be using. First thing you want to do is in your base test static constructor, like James was saying, in order to save time, you only want to launch the driver once. For any testing session, for any series of tests that you're running, you only want to launch the driver at the very beginning. You don't want to launch it at the beginning of every test. You want to launch it just the once. So you want to put that in your static constructor of your very base test object. And you just create a new driver object. You have the options to configure it. You can send it command line options. You can give it a driver file path. There's other things you can do with it. And then you want to navigate to the very first page. So what the user sees when he types in the URL of the page it's usually like a login page or a home page or something like that. You want to navigate to that page in that static constructor. And then you want to initialize common page objects, usually like a navigation bar or any other object that would be shared by every page. You want to initialize those here. And then in your base page constructor, you want to pass in a driver as a parameter, and you want to assign the page driver to that passed-in driver, so that every page object is using interactions with the same driver. That allows it all to be run in one consecutive testing session. And then you initialize the page factory, which we'll get to very soon. And you also want to initialize common wrappers that you may or may not have. For example, James and I, we had a weight wrapper that was actually created by Jeffrey here to make the weight statements less ugly. So we initialize that here in our base page constructor because all of our pages use that weight wrapper. And so
do
now
the
we're
demo?
gonna go ahead and show a quick demo of how exactly to set that up. I'll show you some code.
So we've got some steps done already, just to start with. This is our sort of little demo project. We have a base test class and a base page class. So you can see here the base test class, it is a test class, a Microsoft UI test, or Microsoft unit testing test class. We have a reference to the driver, and we have this static constructor here. This code here is to find the file path to your driver file. We should talk about that for a moment. So the driver is actually a piece of code you have to go get and download. It's an executable file, and you need to start up your driver object in your code by passing in a path to that file. And that's how it knows to start. There's been a little bit of confusion. It seems like this wasn't true when we started, but when you install the packages, you don't actually need to have the path anymore to start up your Internet Explorer driver instance. So maybe do some research on that. But we had to when we were doing ours, certainly, to pass in any parameters like private window. We definitely had to do some things, and we needed a path to it. So that's how you start it up. And then we got our driver, which is held at the static level, available for all tests. What else have we already got? Base page, that's just a stub.
So is the Selenium specific to just Internet Explorer, or can I use it
No.
in browser?
Any browser, but you'll have to have a different driver file for each type of browser.
So there is a Firefox driver,
Yeah,
.exe that I have to download.
exactly.
Okay.
There's also support for headless browsers. If you didn't want your tests running in the forefront like they will be here, you can download one of the many headless browser drivers that are out there, and then your tests will just run in the background. That's usually ideal for automation, but sometimes that can be outside of the scope of your project.
Do headless browsers actually run on JavaScript?
Yeah, some of them do. You got to find the right one. One that we were looking at specifically before we were told, no, actually, we want to keep using Internet Explorer. We don't care if it's slow, was Phantom.js. That seemed like a very reliable headless browser, but we can't testify to that firsthand because we didn't use it.
Just to extend off of Jennifer's question, first, does there one that supports Edge, I assume? Is the IE one compatible with Edge?
You probably have to have an actual Edge one. I am not sure though. You should research it if you want to do that.
So I'll assume that there's one out there, but then to add, extend off of that, how easy? I assume you only did it for IE here.
Yeah, this is just for IE.
How easy would it be to wrap every one of your tests in?
I think it'd be pretty fast. You pretty much should just have to do this step with a new driver instance where you make the driver from that type, and then you should be able to pass that in, and all the tests will use it the same way.
So the only difference would be I would construct a driver for different type.
Yeah.
So you will create a base IE test, you will create a base Firefox test, and then you will the test on the other side, the test program that calls it. Will call all of the 6 or 7 or how many other browsers you got, all those tests will be executed, right?
Something like that.
And I have one last browser question. What if I want to run different browser versions or something? Yeah, right.
That's a good
Because
question.
this will run the current installed
Yeah.
version.
Yeah, so this will just open up the browser that you have currently installed on your machine.
I think I've seen some like Stack Overflow posts talking about that same question,
Right.
and I remember. Well, we haven't tried this, so I don't really know. But I remember reading that like that's hard to do with IE because of some way that in which Windows interacts with what you have installed. But with other browsers, you can just pass in some variables when you start the driver to tell it which version to use if you have the different versions installed.
Okay.
But I think
there's something called Source Labs, with which if you connect the I mean, they run Selenium tests, so there you can specify specify the browser version, operating system, can specify anything. So it will be like 4. If in different versions, it will do the job.
Is that Sauce Labs?
Sauce Labs.
I think I saw that as well.
Sauce Labs is what, is licensed or open source?
License.
Okay, so did we buy a license in Salesforce? Okay.
Cool.
Yeah,
All right.
that's actually an important aside. Selenium is open source.
Yeah.
So worst case scenario, if you really wanted to, you could just go in and build something yourself. Somebody probably already has done it before you, though. So look around.
Yeah. Well, to get back on track here, we also have some resources set up, which is just sort of the texts that I need for the URLs to go to for the demo we're going to do, and the login info for my dummy mail account. So let's go ahead and start this off. At present, if you just run that test, all it does is start up the browser window. Here we are. It doesn't go anywhere, and it just stays open. The test is already completed and passed. We just have this window now. So I'll close that out. If we want it to go somewhere, it's pretty fast. Driver.navigate. Oops. Navigate. Go to URL. Grab my property. And now it'll actually take us hopefully to a login page. Cool. I remembered who I am, which is bad. I want to show the full steps of this, so I'm going to really quick clear that. Anyway, so
programmatically clear the cache for a browser.
That's a good question. I don't know if we can do that. I think it only does stuff within web pages, the document object model.
That's actually a good question. Because I think for most people, you're running it in private. In private for you happens to like, you won't remember you, right?
Yeah,
Right.
yeah,
That.
that's
But
true.
most people probably will.
But you should have some logic in your test to be able to tell, like, oh, I'm at the password screen, not the username screen. Do that instead. Or we can actually cover that because it's really fast in this one. So anyway, we've gone there, we've gone to the page, so now we need to create that first page object. I've already got the stub here, which is pretty much all we need to begin with. So I'll just, so notice it has this constructor here that just takes in the driver and calls the base constructor that it's inherited from the base page. So the base page will store it for it. So in the test, all we got to do is now give ourselves a link to that starting page, and set it in the static constructor. All right. And now, when we start our first actual test, we can start it using that page. Login page, and then call all methods or whatever that we need. It'll look the same if we run the test now, so let's just go ahead and move on to the next step of the demo. So let's say we want to use the first text field and type in something. Well, we need to know what that'll be. I stored this somewhere, but it's not too hard to grab it this way. I forget where I put it. So let's inspect that element and grab the ID. There it is. Can I not highlight Internet Explorer? Oh, it's email. That's easy enough. So in our login, Gmail login page, we want to have that. So what I'm going to do is, oh, we should talk about page factory at this point.
Let's talk about finding elements.
Yeah.
So to do anything with your implementation, go ahead and bring up the PowerPoint back up.
Sure.
To do anything with your page objects, the WebDriver needs to actually grab those elements and assign them to an iWeb element. And that is done at its most basic way through the findElement and findElements methods. This is just driver.findElement, or after you have an element, element.findElement will search the children elements for that.
That's really handy.
You can find elements in a variety of different ways. Most commonly are these 4 ways: via the element's ID, via its class name, via its CSS selector, or via its XPath. And these are all used in a variety of different ways. When you're finding an element, usually just off of the whole document, the whole page, you want to find them in this order. Whenever possible, you want to grab it by ID, simply because that's the quickest and most reliable. Doesn't matter where that element is, if it's got that ID, you can grab it. If you don't have an ID, you can try and find it via the class name. Usually that's not unique. So you'll have to use findElements, which will give you a list of elements as opposed to just the first one it finds. You usually want to use those to get a collection of things that are relevant to a specific method. Failing that, you want to grab the CSS selector, which is less reliable, because if those elements move around in the DOM, then suddenly the CSS selector changes. So that findElement call would probably fail. And finally is the XPath. You almost never want to use XPath because it is incredibly fragile. Usually XPath is just used to grab like the basic children element of something.
Or the parent.
Or the parent.
Handy to do.
Because usually there's a parent element with the ID, but you want its child, so you just grab that element by its ID and then use XPath to grab its child very easily. All of this is better done more usually with what is called the page factory. Because especially for dynamic web pages, elements are constantly deconstructed and reassembled in the DOM, the find element that you have, the element that you have stored that you found previously with findElement, if that gets deconstructed from the DOM, it becomes stale. And if you try and do anything on it, Selenium will throw an error. So what Selenium offers is the page factory, which essentially is something that you put at the top of your page object, and it treats that element like it's constantly instantiated, but what it actually does is whenever you call it, it'll find that element every time you call it to ensure that it is always fresh. And it's incredibly helpful and incredibly useful. It makes your code really readable and simple to do and follow, and it prevents 99% of these stale element errors you'll find. Sometimes, especially with a super dynamic web page like what James and I are working on, sometimes even the page factory will fail simply because by the time it finds that element and by the time the, say, click method is executed, it's stale again. But that's just a pain in the butt. You can just try it again and it'll almost always work. You can use the finds by sequence attribute to find parents and children.
Basically, to use the find methods in order. So like find first the ID of this value, and then from there its children find this class name. It's very handy if you have a thing that just has a class name which is shared with other things elsewhere on the page. You want the one that's underneath this heading.
Right.
It'll work pretty well. And
we can't stress this enough. You always want to use the page factory, except when the structure or the content is complicated enough such that its structure can't be found with the page factory. We ran into a single page where the page factory could not find the content that we were looking for simply because how it was organized wouldn't let us. More
than that. Basically, it's when the content is like it has a sub structure to it, like for example, one page had various a list of various things, each of which contained several of this next type of thing, each of which contained a list of this type of thing. That was all done sort of in a variable fashion. You weren't sure what was going to be on the page, but you knew you had to grab, by this name and that and that. So the page factory things just couldn't do it because it wasn't unique content. So you had to have a greater structure in your page object, which meant that you had to have like a subclass inside of which you were finding things. So it gets complicated, and in that case you can use find element.
But if you do use find element, make sure you only find them as needed.
Yeah.
Again, stale elements
use
is a common problem, so only find the element right before you interact with it.
One very handy way is use a property. So just to have your get method in the property call the code to find it, and then when you use that property name, it'll find it every time.
Cool. So now that we know how to find elements, why don't we go ahead and try a login test with Gmail?
Yeah. So I'm going to put one at the top here using page factory attributes. So the general way is you use this finds by, and it takes some parameters to how equals how dot id, for example, or there's also class name, CSS, etc. And then then you do using equals and give it the value to use for whatever it's using to find. So the ID was email for that text box. So that attribute goes on to the declaration of our element, which is an iWeb element. Email field. So that's how you start that. Then, oh, whoops, this is not in the class. Should be there. Okay. Oh, I listed them right there for myself. So then we wanted to do a method that'll use that and send it keys, for example. So let's create that method, public void enter email. So we'll just go email field. It's always good practice if you're using a text field to first clear the text field. Sometimes web pages leave stuff in there. If you just send keys, it'll do it afterward. Field dot send keys. Oops. It's as simple as that. So now in our test, here we have our basic login test. It's going to start at that login page, so we can go ahead and just use the login page and call our new method, enter email. And I've got that stored as another resource, so I'll just pull it up. Gmail address. Okay, so I'm going to run this, but I'll tell you right now we've skipped one important step and it will fail. No, the window stays up still. So as you can see, we got the null reference error. That's because what we didn't do is in our base page we didn't do the page factory initialization call. All you got to do is call page factory dot init elements, give it the driver and reference to the page, which is just itself in this case. We do that in base page so that it happens by default on all pages. We never have to do this anywhere else. And what that does is while the object is being constructed, it goes and it reads these and basically sets that up for you so that now when you call it, it'll actually find it with that data. So let's run it again, and hopefully this time it'll actually enter that text. There we go. So if you notice, right now it's just doing the test, and then the test completes and the window stays open, and I have to manually close it each time. Obviously, you don't want that on your test project. What we haven't done yet is done the constructor. I wanted to show you how that works. So if you try to do a static D constructor, it complains because that's not a thing that you can actually do in C#. the modifier static is not valid on this item. So the workaround is you create a little private class which itself has a destructor method, and in there you do your driver.quit. Then all we have to do is make sure that our class holds a static level instance of that class. So that way when the class is destroyed, oh yeah, thanks. Then it'll also get rid of that. Oh, because this has to be private. And it'll call that destructor. Runs the test and enters the thing, and the window's gone. Right. Okay. So next step, we got to click that button, right? Because we put our thing in, and we have to click the next button. So that's not too hard. Just do the same thing again. Only this time the ID, I've written it down. I'm just not going to use it, but you would go into the page and find the ID and everything. So next. Now we can use that as well. It's good practice to have each thing you do on the page be its own method call, rather than having one method that does both. We're just going to do two methods that do each. So that way our specification step can show each of the steps that would be in your test case, for example. So that's button, not click. Notice it's got a handy click method you can just use. There we are. That was really fast. A handy thing I've learned when you're actually writing tests, if you want to be able to like see what's going on, is make yourself a helper method that just calls a quick sleep. Now that's generally bad form to use in your actual test code. You don't want your test to ever sleep. You want to use what's called a WebDriver wait object, which we'll get to in a little bit here, that will continuously poll until it meets something. You know, so if you're waiting for content to load on the page, you would find something that'll be there and continuously try to find that object until it succeeds, and then go on. But for the purpose of our writing code, so we can see what's going on, it's fine. So I've got a little pause method that I use so that when you've done a thing and you want to see if it worked before the window just closes on you, you can do that. Boom. Now we can see what the next step that we have to do is, which is pretty much the same as that, only you enter in the password and click sign in. Which I'll try to go through really fast here.
So are there any questions that you guys have about this process real quick while James is finishing up this page object for the sign-in page? Excellent. You can see the process is pretty straightforward and quick.
Especially if you're just copying stuff you did before. Okay, so we're almost through here. Long page, enter password. Or I've also got that stored as properly.
Covering this in the next slides, but how is the pass fail communicated and how is it logged?
How is?
We'll get there eventually.
Yeah.
Yeah.
We'll get there.
where we use Microsoft Test Manager and things like that.
Okay, so here we go. This will hopefully do the complete login process. And there we go. And here we are. So test worked. So you had mentioned before the problem where, like, since this is not a private browser, it's going to do that other thing if I run the test again, or it'll know who I am. And then my test, of course, will fail because the first thing it tries to do is find the email field. So it's handy sometimes to be able to read information off the page and be like, is this what I'm looking at? And then I'll do this. So a great way to solve a problem like that is to give yourself a method to...
Question, if you enter the wrong password, what happens? It won't log in.
If you enter the wrong password, it won't log in.
But what's HTTP response?
Well, currently the way we have it is it'll still pass, but we're going to get to a point where we'll be returning separate page objects, and then ultimately it'll fail then.
Whatever Gmail responds to when you enter the wrong password has to indicate to you that the login is failed.
Yeah.
There's various ways to handle that.
Does web applications do that?
Mm-hmm.
Or do they always return a 200 response?
So you can have it like in this test here, this sign-in button click method. We shouldn't have it returning void. We should have it return the next page object, because that action navigates you to a new page. And a lot of times what will happen is if that page object fails to load, then the constructor for the page object, which is waiting for something on the page to say that it loaded, will fail, and that'll cause your test to fail.
Okay.
But we're getting
another approach.
That's getting ahead of ourselves a little bit.
Okay.
Or you can in that method wait for like an error message to show up. So have one here that is the error text thing, and kind of watch it, and if it shows up a text, you can throw an exception and say your login was bad or something, or if it doesn't and the next page loads, it can return the page object. So there's various ways to handle it. Oh yes, so what I want to do is have a method that tells me if I'm on the email part or the password part. And that'll be pretty fast. All we got to do is tell whether the email field is displayed or hidden.
Similar methods like this will be used for the error messages as well. So for example, if you have a test that should fail, you expect it to fail because the test is an incorrect password. You would have a method much like this to check if that error message is displayed afterwards, after the failed password, and then the test would assert that that is true.
So here we can just check that right off the bat, and if it's there, do the first two steps, and if it's not, skip them. There we go. All right.
Cool. So that is working pretty quickly. But what if the page is slower than the code? Because the code is incredibly fast, and not every page is as efficient as Google's expertly engineered pages are. So that's when waits come into play, and it is very tempting to do thread.sleep, but that is incredibly bad practice because you're going to be waiting a lot, and all of those sleeps are going to add up, and suddenly your tests are going to take way longer than they need to. And there's also no guarantee that those sleeps will work. So what you should be using instead are explicit waits. And explicit waits are beneficial because they only take as long as they need to, and if they fail, that's usually an error with the test anyway, so you want that exception thrown, as opposed to a thread.sleep, which after that time it'll keep going with the test, and you won't get the failure that you would be looking for. So the WebDriver has a lovely WebDriver wait object, which you can configure with the common page driver, and you can give it a timeout duration, which is an extended period of time that it will be waiting for, maximum. You can give it a polling frequency, which is how often it will check a criteria. And then once Once you initiate that object, you call its until method, and you give it a criteria, which is a lambda statement. Then that wait object will check that criteria at the polling frequency that you give it. I think by default it's like half a second, until either the criteria succeeds or the duration is hit. The timeout duration is hit. If the timeout duration is hit, or if the criteria fails, well, no, if the criteria fails, it'll keep polling. If that timeout duration is hit, it'll throw a timeout error. And you use this most often to wait on elements. Every page object in its constructor, you want to be waiting on an element with the wait object. You want to be explicitly waiting on an element that's unique to that page so that you can tell if this page loaded or not. And you put that in its constructor. And if that timeout fails, then you know this page did not load, so something happened with the navigation. And that's a test failure. That's a genuine test failure. You also use it to wait in dynamic interactions. So if you're playing around with a lot of AJAX stuff, if you click a button and a list shows up and you want to wait for that content to appear, you would use an explicit wait in that instance as well. And if it fails, then the content didn't appear, and that's probably a genuine test error. That said, despite it being used commonly to find elements, you can use that criteria for anything. You can use it to see if something is displayed. You can use it to see if values are equal to each other, etc. It's just a lambda expression. So you plug in whatever criteria you want. It'll check that criteria according to its polling frequency, and if that criteria passes, great. The code will continue. The wait's done. If it fails and that duration is hit, then it'll throw you an error, and you can usually debug it from there. So using that, we are going to go ahead and do some more demonstrations. I believe we have a search test.
Yeah, let's do the search test. So we also want to test just doing a Google search and getting the result page and waiting for that page before we click on the next thing. So we have to make a search page. I don't have a stub for that because I wanted to show at least one making of a page from scratch. But it's pretty fast. All right. Put it down there for some reason. Okay, so we want to do inherit from base page. We've got to give it its constructor that inherits. All right, and this will have, I think I stored the IDs over here, all those. This will have a search field that I'll put in right off the bat here. One thing we have not mentioned so far is that for our project, we had to load a couple of packages with the package manager, namely Selenium.WebDriver and Selenium.support, and that's where I'm getting all these things, the OpenQA.Selenium, etc. All right, MOSTIB. All right, this will be our search field. Okay, let's put in a method to type in some text, just to start with. And then we'll need to navigate to that page And let's say we had many pages that started from search test. We would want a helper method for use in our actual test code that would just take us there to start off our test. And you put that in the base test, or if you have like a sub class that is a base test for this subdomain, you would want to put it there if it's specific to those tests. We'll just put it in base test. That's what we have. We'll make a method that is it returns this search page because it's going to go there, and it's just a go to search page method. All that does, will do driver.navigate, and I've got this as a stored resource as well. Search URL, and you return a brand new search page. Boom.
So the driver navigate on a URL, how does it handle redirects? Following the redirects? Is that
Well, the navigate method just all it does is pop in that address and tell it to go. And then wherever it ends up from there, it's your responsibility to know that you're going to be on this page and have the right page object that you've made return from it. So it doesn't handle that.
Okay.
It just
if I
kind
want
of,
to follow all the way to the end of the redirect, I have to do it.
yeah, you have to know where it's going to go and make a page object, or have a way to tell where it went.
No, hold on. The web control is supposed to follow redirects. Right? It's going to pop up a web control. That's what it does. I mean, when there's a redirect, the browser is supposed to follow redirect. It should not wait for user input at all. So it will follow the redirect.
Yes, I mean it will follow the
You just have to
redirect.
take into account the time it takes for redirect. So you wait for some time and then start inputting your information on the redirected.
Yeah.
So yeah.
So that's handled by returning those page objects.
Yeah.
That's what tells the driver we're on this page, is through how we're interacting with all the different page objects. Some methods that cause that redirection will return the expected page object. So you, the programmer, have to keep track of what buttons will take you where.
And make sure that you make the right page object. If you make the wrong one, your code doesn't know. It'll only find out when you try to use something on the page and it's not there.
So the driver, because we're using a single driver, the driver always knows what page it is on. The problem comes when, in the code, if the driver is on one page but your code thinks it's on another, when you try and do anything with that page object, it'll fail because the driver won't find those elements. We have been bitten by that before.
Yeah. So there's tests that you can have if you're not sure where it's going to go. Like, depending on if my login was right, it might go to the next page, or it might just give me an error dialog. So then you can make a more complicated wait statement with several lines of code where you basically do two things. You wait to see if you've got this thing that's on the next page. If it's not there, then you can check to see if there's a dialog up showing a message. And depending on which one of those it is, you might return the page object, or you might return null or false or something. And if neither of them are there, you just return false and keep the wait going. So it's like a way to wait on two results.
What you're generally doing for each test is you're starting from you can go ahead and keep building this. You're starting from a base place because every test needs its independence. You need to be able to run every test independently, but you also need to be able to run them all at the same time. So every test has like a base area that it's starting with, and that's part of the reason for the second layer of inheritance for the base tests is a commonality for some errors. For some areas. So for example, for the project that James and I are doing, there's a projects area and there's a playlists area. So we have base test classes for projects, base test projects, base test playlists. And those areas, the tests that inherit those base classes assume that you're on that page. And they have navigation methods that'll take you to that page, and they also have helper navigation methods that'll take you from that page to the page that the individual test starts at. And the way they do that is they simply click on a button and return the page that they're expecting to get. If any of that fails, well then the navigation is broken because it's not navigating how it's supposed to be, right? And that's a genuine test failure. So basically, we handle navigations. The driver is always aware of what page it is on. Whenever you try and find any element, the driver doesn't need to be told what page it's on. It just starts looking for that element on that page. The code needs to be told what page you're on, and you do that by returning page objects. Does that make sense? Okay.
So here we've got our search test. I placed in some pauses just so we can see what's going on. Normally you wouldn't worry about it. So let's take a look at it. Did I do the wrong one? Oh yeah, because that was, yeah. Okay, so go to Google. It's pausing, and then type in Elias. It worked, right. So that's cool. Notice that as soon as you started to type into Google, it switched away to a different thing. So if we try to click the button that's on the page later, that'll fail. So instead of that, I'm going to make a method for completing our search and returning the search results page that just hits the enter key. Should return. Since we don't have a search result page yet, I'll leave it void for now, but it needs one. Hit enter. So let's do search field send keys. That's handy. Yeah, okay. And then still got, I'm going to take out that first pause because we saw that. But pause so we can look at what happens at the end still. That didn't seem to work. Oh, because I didn't call the method. Okay, and there's our result page. Excellent.
Just a quick question.
Mm-hmm.
Is there like special syntax for enter? Like, can you do Elias and curly brace enter, and it will send enter at the end of Elias? Or do you really have to write a method?
You probably don't have to write a new method for it. At the very least, you could include it in the same method, and there might very well be a way to put that in as like a code call or something. I haven't researched
I think
it.
it works in code devices.
Okay. I actually want that in its own method because I want to be able to have that method return the new page object. Although you could encapsulate all of that in one. I guess, yeah. All right. So let's make that new page object really quick. This one's going to be pretty bare bones because all we really want to do is be the search result page. Oh my god.
Very rare pure.
Okay, so now we can return that from our from our method. Return result page. Excellent. And then the test.
We haven't initiated the page record yet.
It should be in base page.
Yeah, go to base page. We have yet to initialize that page.
Oh, it's called page driver. That's why. Yeah, that's there. It gets set right here. I just forgot that we had named it that.
Okay.
All right. Okay. So now in our test, when we hit enter, we can get our search result page back to use for the next step of the test, if we want. From that method. And that's how you would keep going for next steps of the test with your next page object. Test will still look the same, I think. Now we have that framework put in. Except it failed.
I believe you have to set page driver to be passing driver.
Oh, did I? Ah, that's what you were telling me to do.
That's what I was telling you.
You're entirely correct.
So just to emphasize,
Very
we
important.
want to use the very same driver so that we can chain multiple redirections in a single test.
Okay, so it worked, and now we have an instance of search result page. So next step is you want to, let's say, click on something on the page. I want to do this because it'll demonstrate the next point I want to drive home about weight objects. So let's give ourselves a method that just clicks on a link. Public void click link string link text. There's a handy method you can use which just finds a link by its text. And we'll click on it. All right, and then in our test we'll make use of that. I know there's one on there called alias, so we'll just click on that. So theoretically, that'll work. Problem is, it couldn't find it, and if you notice while you're watching the test, it didn't even have time for the results to come up. It just immediately had the error. That's because we didn't wait for the page to load. So to use the page weight, or to use a weight object, you want to put it into base page so it's available to all pages. Have a reference to it. And when we start up any page, we will set that up. Give it the driver and a timeout, which has to be a time span. Let's just give it 8 seconds, because why not? So now we have a weight object that we can use, and in our search result page, before anything happens in the constructor, we want to wait for the page to load. I went ahead and wrote down, which is now gone, except I wrote here, an ID to wait on, but normally you have to scout that out and find something that is only on that page, or at least not on any page that you would come to that page from, and wait for it. So we're going to wait until, and give it a lambda function. The input is always the driver. So D will be the driver, and I can go D dot find element ID. It'll find that thing, and basically, if it finds it, it'll pass and go on. If this throws an exception because it couldn't find it, then the wait object will catch that and just keep going, keep waiting. All right, success.
All right, so yeah, that's how you use weights. You want to put them again in the constructor of every single one of your page objects, because you want to make sure that those pages load properly before you can actually interact with them. Yeah. And simply putting that weight object in those constructors will also catch any navigation errors that you have, because it'll throw exceptions if you're ever on the wrong page, and it's incredibly useful, especially for debugging. Super useful for debugging.
Yeah.
Also, never assume that the element you have is actually unique. One problem that James and I ran into a lot was previous tests actually changed the HTML of future pages, because the HTML that was injected was never actually removed, and suddenly what we thought was unique was no longer unique, and the wait would continuously fail on us. So always make sure that the wait is a unique element.
Or the wait would succeed too fast.
Or it would succeed too fast.
The thing I was looking for was already there, just hidden from something else.
Okay, so finally we're going to talk about actions. The WebDriver, the iWeb elements and the WebDrivers do have very simple actions that they support, such as clicking or sending keys. But sometimes you want to do something a little more complicated. Sometimes you might want to click and drag something, or double click on something, or hover your mouse over something. In that case, you want to use the WebDriver actions object. The actions object is a very simple object to set up. You just create a new action, like it's an object that the WebDriver has. You create a new one of those. You append various actions to it, which are just represented by methods of that object. So you would say action builder dot move mouse to here or something like that, and you'd append a series of those actions onto it in the order that you want them to happen, and then you would call perform, and the action will execute the actions that you gave it in the order that you gave it to them once you call perform. You can also assign this this action builder object to what's called an iAction if you wanted to, say, click and drag something over and over again. So instead of calling perform, you call build, and it'll return an iAction, and you can store that and use it over and over again. And then you just perform the iAction. Don't forget to perform. I'm using that word a lot because James especially always forgets to perform.
I'll build this whole thing, and I'll go and I'll test it, and I'll go, why isn't this working? It's doing nothing. I've done this like 5 times where I just forgot to do perform.
So we've got one final demonstration for you guys, which is mousing over the I'm feeling lucky button on Google search page. If you mouse over that button without clicking on it, the I'm feeling lucky will scroll. So we want to show you how to do that using actions.
So we can plug that into the search page, same page. It's convenient. We need to find the I'm feeling lucky button, which I went ahead and scouted that out earlier. It's this
Very
ID.
intuitive ID.
Yes, should be QFID. So I'll just put that into the search field as a new thing. I'll do some copy pasting here and make this faster. All right. All right, so what we need is an actions object, first of all. This class will own. And we'll need to set that up when this is created. So there it is. And then we can make a method. I'm going to make 2, one to move the mouse over it and one to move it off, so we can sort of see it in action. I'll like void move mouse over button. So do actions. It's got lots of options here. You can click and hold, double click, drag and drop, all these things. This is really cool. What we want is move to, you can move by offset or you can move to something. So move to element, lucky button, dot perform. Oops. Capitalized. And then, so we can actually see it go, I'm going to use that pause method or a pause method. This doesn't have that method. I'll just copy it. Normally, though, you would never want to use a thread.sleep in your actual tests. In this case, it's kind of appropriate because we actually want to sit and watch it do a thing for a given amount of time. But I feel guilty doing it in front of you. Just wanted to say that. Okay, cool. Then I'll do one to move it off by a certain amount off of the button, so we can watch it go back to normal. And I'm going to use the other one, move by offset, which is really handy. You just give it some coordinates. Let's move it 150 pixels to the right. Then we can make a test that uses this. So it starts the same way. I'm going to grab a search page by going to search page. But then we can go search page dot mouse over button. Oh, saying that I didn't. Yeah. Thanks.
Sorry.
Doing it again.
See?
Yeah. Then let's move it off. And back on again. Okay. Oh, I didn't. There it is. Let's see if it worked. There we go. So there you go. Mouse hovering in action.
On that. Okay.
Yeah, it doesn't actually move the mouse that you see. There's like an invisible Selenium mouse. But,
Okay.
yeah.
Anybody feeling doodly in here? Cool. Yeah. Okay. So that's how you use actions. It's incredibly useful. We've had to double click and click and drag and do all sorts of stuff. So we just have a few actions for that.
We've also had times where a button that we had to click would be hidden until the mouse rolled over it, and then it would change format and show up. And Selenium can't do anything with it until it's not hidden anymore. So we definitely had to use actions for that. Yeah.
And yeah, that's pretty much our presentation. So I guess we'll take some time for questions if you guys have any. But I'm pretty sure our presentation was utterly spectacular.
So yeah, I want that question answered. How do you log the results? Who calls these tests?
Oh yeah.
How are the results logged?
So what at present, when you're starting out with this way, and what we had for a while is it's just a Microsoft unit testing project that you would launch over here in the Test Explorer,
Okay.
and then that creates a test results folder you can look at.
Okay.
But we are now also in the process of getting this run and logged from an automatic build process. So we've got a PowerShell script that we've made that launch these tests using the MS test.
Okay, can we integrate this with the gated check-ins? For example, when someone checks in code, sorry?
Yeah, you should be able to implement it just like any other unit test project.
Yeah,
Okay.
we've got ours under
Assuming it's
source
part
control
of
that way as
it's a
well.
part of that project.
Sorry.
Of that solution. Yeah.
Yeah.
Okay.
Yeah.
In James and I case, we don't have access to the solution of that project, so we have to use a PowerShell script and an automated build definition that coincides the build of the project with.
Okay.
In the
that.
one of the next steps is the build definition for that project will also link to our PowerShell script and launch it remotely on whatever machine we end up installing this on.
But yeah, this is the MS test framework. It's just like you're probably familiar with. You automate it and you run it with check-ins just like you'd run any unit test or anything like that. All of these are test methods, just like you think they are.
And for logging, this makes a test results file, the TRX file, if you let it. I think there's some configurations you can have where it doesn't. We've got ours set up so it does. Then that'll log all the results of tests, and you, if you want to, can add in code, just anything that prints output. Console write line.
To that file?
Yeah, that'll go to that test results file and to the actual test it ran in. It'll be part of the general output tag in the XML of that test in the TRX file. So that's pretty handy.
Have you done any work with figuring out if you can do code coverage with this, like identifying exactly how much of the project you're covering with these tests?
Well, if this is a unit test in the same project or same solution, I think you could plug in that functionality just like it already has built in. But like what we're doing, where it's an entirely separate project.
I think the code coverage will come out very less.
Yeah.
Because it's not calling any of the methods.
Oh, that's true. Yeah. So even if it was the same project, it probably wouldn't be able to do that.
There was backend debugging what a UI test experience I had, we went, or not me specifically, but we went through a lot of effort to instrument the code in such a way that even though we weren't explicitly calling the methods, it would still log coverage results. Because there is something running, right? So we'll instrument that as you called it externally, and then those results would be aggregated with the unit test coverage results, and then you could get a total. I'm covering this much unit, I'm covering this much with an actual user clicking things, and then you could figure out how much you're actually testing. But that's cool. Kind of like a next step, I guess. I assume you probably have.
Yeah.
Well, I don't think we'd ever get that far because again, we don't have access to the source of our project.
Right. That also. Yeah.
Which has been a pain in the neck a couple times, but you don't really need it. Like we're testing Google right now. Obviously, we don't have access to Google's web source code.
Right. Obviously.
Yeah, but I guess you already knew the answer to that question.
Yeah, so it probably is possible. Yes.
I would actually, I would also be surprised if there's not like some way to interact with views or log results that way. I don't know.
And one more question is what did not work? So for example, Red Prairie was actually the most difficult thing to automate. So Selenium is good for certain things, but what is it not good for?
Well, Selenium just automates browsers. So if you don't have a web application, you're not going to be using Selenium.
Okay.
It's pretty much that simple. If you can do it if you can manually do it in a Chrome browser or whatever, you can do it with Selenium. If you have a local application, Selenium won't be able to handle it.
So Red Prairie was completely local. It was not web-based.
It was web-based.
It was web-based. So what was the difficulty in Red Prairie?
Sometimes I couldn't find elements on the page because I think just the way that the app was designed, I think it loaded some things differently.
Okay.
Yeah, I'm not too familiar with the.
I remember you saying that like it was impossible to find how to grab certain things on the page because it just like you couldn't see it in the F12 DOM Explorer and everything.
Yeah.
Because the way the app was designed.
I mean, I guess that also kind of brings up, this is probably outdated, but Selenium interacts with the elements of that web source, so you can't like play a Flash game with it because the Flash game won't have elements that Selenium could access. I don't know if Flash is a thing in Red Prairie. I would be surprised if it was. But anything that you see on that web page that's not part of that web's source, you're not going to be able to grab.
And there's also stuff like, if your page does a pop-up, like file download window or something, Selenium can't control that.
Any elements that are not part of the initial page download will not be recognized.
It couldn't upload.
Well, we actually had that problem, and it turns out that while it can't control the window for selecting the file and everything, you can still test upload by because of the way that the HTML element for that works. You can just send it what would be the result of that window, the file path, to do it.
Sorry.
That was all.
Oh,
yeah.
I was just going to say that because this is an MS test project, couldn't you actually control on the mouse, click that window?
That's something I've thought about. You might be able to plug in some like, console app kind of like find a framework that does robot control for those sorts of situations. We haven't done that. It's a good idea.
It was easier to just send keys to that file upload element
with a
relative deployment item path, and that would upload the file for us.
But if you wanted to, so like for our application, you can upload an attachment to a review, but then you can come back into that review and see listed attached files. You probably want to download it and say, oh, yeah, the thing I uploaded is the thing that was uploaded.
Sure.
Yeah. So you would need to re-download it, so you'd have to get around that problem.
Sure.
Yeah. So you'd have to come up with something more beyond Selenium for that.
But because this works with unit tests and MS tests.
Yeah, you can use multiple tools and get that done. Absolutely.
So does the you can find elements by text. I'm wondering, the question I had was, does that support regular expressions or is it just verbatim? This is an exact match for the screen.
Well,
We haven't used regular expressions, but I would be very surprised if there is no support for them anywhere. Like, I would be shocked if Selenium doesn't let you use regular expressions for anything.
You could probably even like not relying on its methods for that. Like just the string you're giving it as the text to look for in your code level. Do some. Well, I don't know. I'd have to think about that.
This is like important for find by ID. It's like sometimes you prefix an ID with it's like table row or something one.
Yeah.
And so you'd want to search for all table rows, and you could do that by class, sure, but maybe you've got two tables.
And, yeah. And those are just strings. So if you can construct the string you need for the ID, you can do that.
So is the DOM that the WebDriver? It's not the real DOM. It's like a parallel structure.
I think the WebDriver does view the DOM that the browser would see.
Is that available for you to traverse in the case of, say, I do have, like, I don't know.
Indirectly, certainly, you could at least get around with XPath and such things to traverse the DOM. And you can...
Maybe this would be worse.
I mean, if you wanted to do all your tests by moving the mouse around and clicking, you can do that with actions, really. Any user interaction can be simulated. There are just better ways to do it, typically. Especially in the case of regression testing, because you can't be guaranteed where an element is.
Yeah. The DOM might change, but it still looks the same and has the same text on the button. If you're finding it that way, then you don't have to change anything.
Anything else? Good. Thank you, guys.
Yeah, thanks.
That was awesome.
Thanks for showing up.
Yeah, thanks for coming. It was good.
That's great. So let's upload the video to YouTube or some public place.
All right, we'll get that.
And also, if you can upload the demo solution.